Hello, Technology, Engineering, Science. Today we have with you Christian and Mitchell. Okay, first thing we're going to start off with is our favorite part of the class. And my favorite part of tech personally was the Arduino. Just the fact that you're able to wire it up in different ways and use knowledge that you learn and apply it to an actual solution. So that's why I like that.
And my favorite part was the Minecraft aspect, where we just got to go and defeat the dragon, which was pretty baller. And also the creation part of it, where we can go create or the redstone, that's what it was. We created a redstone contraption and we presented it to the class. It was pretty cool. Alright, now we are going to gut Chris's computer, and we are going to pretty much label every component and explain what it does. Alright, we'll see you soon.
Hello! Alright, so basically what we're going to do now is we're going to completely unlock the secrets of the Great White Beast, which is my computer. First off, I'm going to actually disconnect. Oh, that's in there for good. Never mind. I'll just slide this over here. So basically, this is my machine. It is kind of tiny for the actual case itself, because I was hoping for expansion, which hasn't happened yet, but it will eventually. But basically, we're going to run you through the components inside the actual computer itself, and just how it works inside the computer. Alright, so first thing we're going to start off with is one of the most important parts of the computer, and that is the CPU. Alright, now it's not this big thing because this is called the Thermaltake, but it's underneath here. Now basically what the CPU does is it has a bunch of transistors on it, and transistors are able to hold a single bit of data, and a bit is 1 or 0. One of those two values, and that's how pretty much every single piece of technology code works at the lowest of the lowest levels. Okay, so this is a AMD Phenom 2 Black Edition CPU with a 3.3 gigahertz clock speed. Now that just means it's able to do about it has 6 cores, so it can have 3.3 gigahertz, that's 3.3 gigaflops, which is how many processes it can do in a second. And you take that times 6, and that's how many cores it can do. Or that's how many processes it can do with all 6 cores. So we're going to move on from the Thermaltake and the CPU region over to here. These are my RAM sticks. Now I'll actually be able to take one of these out for you guys and show you what it looks like. Now this is Vengeance LP Corsair RAM. This is a 4 gigabyte stick. So basically what RAM does is it stores data. So RAM is actually called Random Access Memory. That's what the acronym is for. And this basically stores integers from the start of the computer till you shut it off. So every time you shut your computer down, it drops every single piece of data that it has in its RAM. Okay? So it's pretty easy to put back in. You guys have seen RAM before. So once again, what this does is it just pretty much takes in it pretty much lightens the load for the CPU. So it takes in processes and holds data that then goes into the CPU via a serial bus somewhere around here. It's basically just a highway that data goes to transfer through here. And once you shut your computer down, the data in the RAM actually drops out of existence completely. So people make RAM hard drives, which are extremely fast because RAM has to be fast to keep up with the CPU.
RAM disks.
Yeah, exactly, RAM disk. And so once you shut down your computer, you lose that RAM disk because RAM functions as it said. Once you shut your computer off, once it loses power, it does not store any permanent data. Okay?
Hold up. Just for note, there is a difference between laptop RAM, what was this, tower RAM, or
they're just desktop RAM.
Desktop RAM, and then there is also server RAM, which each one pretty much operates at a higher speed capacity and electronic capacity.
Electric, yeah.
And it just, I don't know. I mean, it's just, that's what it is.
I think it's the same function. It's just different personalities for each different system.
All right. Keep going on.
All right. So this is the big honker. This is the graphics card. This is the AMD HIS Sapphire HD 6870. It's not the highest class, but it functions for my gaming. So that's all I need it for right now. Basically, it is what it says. It's a graphics processing unit, a GPU, and this takes in inputs from the actual motherboard system itself. So it's a giant system that sends in data here, and this decodes it and outputs it from the back here as video data. So each one of these prongs leads to a cord, and that cord connects to a monitor, and the monitor once again decodes that data into actual pixel quality. Alright? So pretty much GPUs come in many ranges of sizes. This is once again a lower end version, but it still functions as it does, giving me good video display as good as it can. But you can go anywhere from like pristine, I don't know, is 7970 still top of the line?
Mm-hmm.
What is?
There's eights out now.
There are?
There's eights out now,
Oh
yes.
my gosh. So
Technology is advancing so much.
Moore's Law, kids, we'll learn about that in the future. So, yeah, that's pretty much the purpose of our graphics processing unit.
Well, with graphics processing, you can basically, the more that you pay, the better processing you'll get. The more you'll be able to run at higher quality, and the more pixels you'll be able to display on a screen. You can run multiple monitors, which 4K is the one that's big right now, correct?
Mm-hmm.
How big is the aspect ratio on that? Do you know?
It is a 16:9 still aspect ratio. Just the PPI of it is super tight. Like it.
I thought it was like 21 by something, but I don't know.
I think that just depends on who's making and how big the monitor is itself.
Okay. Do you know what the resolution is? I'm gonna guess somewhere in the
4,000.
4,000s. But
Yeah, very high.
very high. So yeah, graphics processing power has come a long way. With graphics cards, you can. Chris does not have it, but you can enable multiple graphics cards through. What's the AMD version called?
Crossfire.
Crossfire, and then for NVIDIA, it's called SLI, which basically you can use 3, 2, or 4 graphics cards as one. It's a very, very neat feature that allows
We're getting radio signals. The aliens, they're here. I'm sure.
all right, I'll continue on. Basically, just allows processing to be through 4 cards as one, and it just makes it a whole lot less of and it gives you a lot more power, but it also produces a lot more heat and uses a lot more energy as well.
Right. And you can also allocate some, like say like the CPU is overloaded, you can allocate some of the processing power of the GPU dedicated towards logic processing, so you can lighten the load for this guy. Alright, next we're going to move on to another important part of the computer. This is called, let me flip it up here real quick. This is called the power supply unit. I'm sorry for the dust, it's been a while since I've blown her out, but this is the PSU. Okay, so this is exactly as it says. It supplies power to each individual part of the computer. Okay, without power, these parts would not be able to function, which is pretty logical when you think about technology if it doesn't have power. But this is one of the most important parts, yet it is very simple in theory. So it takes in an input and then outputs a certain voltage to each individual part. And basically, if I take this is a motherboard power connector. This actually talks to the motherboard, and this then sends back signals to this, which regulates the power. So if this thing gets too much power than it can handle, it could fry it. And so the reason why these talk back and forth is that very thing won't happen. Alright?
Just for note, you can notice Chris has his fan blade pointing up, which will in return take heat away from the graphics processing unit and push it out the back. Or if you would prefer to have the fan facing down, he would be taking air intake through the air filter down here, and it would lead to less dust, first of all, and also, first off, it wouldn't take away heat from the inside, but it would pull in cool air from the bottom of the computer.
What? Okay.
Moving on to the next, which would be
Storage?
storage. Let's do storage.
Alright, I'm actually gonna take off the back plate real quick. This would be a good time to show the back side if you want to flip around.
Let's go over here.
Alright. Hold on. There's a lot of wires back here. This is where I did all my wire management, so I apologize for the mess that you're about to see. yeah, this
You don't have to take it off if you
this
don't
is how I
want to.
get to my. Wait, maybe nope. Never mind. We're good.
We're good? Yeah, let's
We're good.
just we'll go through here.
Okay. Here are my. Well, I have two SSDs. So, like, see the wires in the back? There's a lot of wire cable management that goes on behind the scenes. But if you can see these, maybe I'll get one out here. These are OCZ Agility 60 gigabyte SSDs. Basically, these are my boot drives. I did have them running in Mir. And Mir just states that whatever goes on this one goes on this one. It's called RAID 1. But the reason I have my boot drive on SSDs is so my computer can start up really quickly. When you have things that run fast and then all of a sudden you have something that runs slow, that slow thing is going to be called a bottleneck. And with a bottleneck, that could seriously ruin your PC because you could upgrade everything and still have that slow thing, and it won't even make a difference of how fast your computer can go.
Branching on that, basically let's just say you get a very, very, very expensive graphics card. Let's go $900, right? But you get a $150 processor. It's just like, that's going to be a bottleneck for you. Or you get a very nice processor and a very nice graphics card, but your motherboard cost $80. It's gonna be that. It's just like all that processing power is not going to be able to go through the motherboard at a stable rate, which is in turn called a bottleneck.
Correct. So I have these 200 here, which is my boot drives, and then behind this plate I have three Hitachi 750 gig SSD, or not SSDs, HDDs, which are just hard drive disks, and it's basically it writes the information while it disk spins, and it has a needle that keeps on poking in. And basically, when there's a divot, that's a 1, and then when there's not a divot, that's a 0. So it's still run at the basis of binary right there. I have these run in RAID 5. Now RAID 5 basically says I only have 1.5 terabytes of data, and the other one's a backup, or it is. I think it actually. Correct me, or not correct me, but I'm going to correct myself. I think it gives me all the data I need. So, 2.5 terabytes, or no, 2.25 terabytes.
Sounds about right.
And when one of these hard drives, if it were to fail, the data would, like, I would lose 750 gigs of hard drive space, but the data would be backed up on this hard drive, right? So it's pretty much a backup for if any of these fail. So it's like, it does algebra, so if like it's 1 plus 1 equals 2, and it writes on the other one, and all of a sudden one of my one drives goes down, that's going to be 1 plus x equals 2, and it's automatically going to do the algebra to figure out what's going to be written on that other one, or written on the drive that was lost, and it's going to put that data on top of the answer drive.
That is insane.
Yeah, RAID is awesome. And then we're going to save the best for last, which is the motherboard, but we're going to go to this thing. Right here.
Oh,
Sorry.
right here? Okay.
This is a basic optical drive.
Yeah.
Takes in CDs. This is a Blu-ray drive, so it can take in CDs, take in Blu-ray discs, it reads them, pushes it through a SATA cable, which goes to this thing right here, which then goes through the motherboard. So it basically turns optical data, which is again the ones and zeros from the actual CD, into digital data, and pushes it through the processing system itself.
That's right there. All right.
Ready for the last one?
Last but not least.
Definitely not least. We could do another one actually after this, but this is definitely way more important. This is the motherboard. See everything with like this green piece of PBC, which is printed circuit board, PCB actually, and it has a bunch of transistors and crazy capacitors and amazing things that runs through it. There is this thing called ROM. Now, if you weren't in AP Computer Science for the first semester, then you may not know the difference between ROM and RAM. So RAM loses its memory after that. ROM is called hold on, I can remember the acronym. ROM. Read-only memory.
There you go.
So on boot, like to get the actual computer, like the BIOS of the motherboard, which is basically a small operating system before you get into like Windows or Macintosh or Linux. This is what pretty much tells it to start booting from, you know, this drive which has the operating system, or these two drives actually which have the operating system, and so it pretty much kickstarts everything. So read-only memory never gets lost, and it's always the first thing that the computer reads before it goes into these guys, and RAM drops. So the motherboard itself is like the highway system of America. It allows these big cities that may be exporting and importing different goods to actually be connected and intertwined. So the highways and the interstates would be called buses, and those are basically ginormous highways where electrons can flow through to equal ones and zeros to go through the millions and millions of transistors on top of the CPU, to go to the RAM to get stored, to go through on the PCI slot for the actual graphics card, to go to the hard drives to get stored. It is the connector between everything. It is the link that keeps everything going. And so, like Mitch was saying, if you have the bottleneck of like a slow motherboard but you have these amazing components, you're gonna get traffic jams.
That's what I was thinking.
Yeah, exactly. So you're gonna have these high amounts of data that want to go through a tiny little one lane road if you have a cheap motherboard. But the expensive motherboards, you know, those are 6, 7 lane buses, 7 lane highways that can allow the traffic to flow freely. And it just blows my mind that humanity is able to, in like 40 years, develop something that can store that much information, which...
It's insane.
It's
very insane.
So the next thing I want to get to is, last but certainly not least, is the case itself. This protects my innards, my guts, and this is the...
Your glory.
My glory, exactly. This is the NZXT Phantom 820 case. We'll do a hit of it while it's lighting up, so we can just show
That'll be cool. Yep.
show you exactly what it does. But that pretty much wraps up what makes up a computer. There's different parts that you can add on to it that just don't...
Well, you can add in fans. You can add in like LED lights.
Yes.
Liquid cooling.
Oh,
That's a big one.
The liquid cooling is huge, but they aren't necessary for actual
No,
computing.
they're not. It's just basically, if you guys have watched Freddie W, he made a computer video. He says to build a very high-end gaming computer, basically it's going to cost $800 to build something that is going to last you a long time. If you want, you can go above and beyond, build something so much better. Like Chris's computer, how much was yours?
It was $1,500 with everything in total.
Nope. Mine will cost a total of $2,500 just because I went overboard on my graphics processing power and my CPU.
That was rad.
And I mean, if you want, you can go lower and just get something that'll just browse the web. It doesn't matter. It's just whatever suits your needs will be great. And I don't know, if you like building things,
Oh yeah.
build a computer. If
Exactly.
you want something that'll be like consistent and most likely won't break down on you, get pre-made. And it's just personal preference, really. If you feel imaginative, go with your heart and build it.
Yeah, it definitely gives a sense of fatherhood or motherhood.
Yeah.
To actually build it, because this is your baby. You work so hard on it, and to actually see the product from where it started with a bunch of parts into...
It's like trial and error. Like, you build it, if something doesn't work, you have to go back and fix it.
Oh yeah.
It's just, at the end, you just have this giant sensation come over here. You're like, I did something that this actually works.
Oh my gosh.
And it's the best feeling.
Oh, it's so good. It actually, like when you actually see it working and playing games, like you built this thing from random parts that do nothing separate, but when together they, you know, calculate pi to the millionth decibel. It's just absolutely crazy. I'm just.
And by the way, at the end of this little monologue we got going on here, we're going to demonstrate some programs and applications that can actually run on a computer, and one of those will be SuperPi, which you basically you tell your CPU to calculate 1 million numbers of pi or 32 million and see how fast it can do it. So with that said, we will move into the application and software side. So this is what Chris's case looks like with the lights on. Flick it off. And that is what
it can turn colors.
custom LEDs looks like on the inside of the computer. But yeah, switch it up. So there we got some, oh dang, nice green vibrance. We got some yellow, red, Keep going. Purple, blue,
And we're good.
and there we go. So yeah, it's pretty sweet. And now we're going to show you some application usage. Alright, so we did the test, which normally we would do 1 million, but to save some time, we just did half that. Alright, now Chris is going to, let's do Catzilla. Benchmarking. He's going to open up a benchmarking application.
Alright.
Alright, so Chris is going to run the application that's called All Benchmark, which is basically Catzilla, which is going to benchmark his computer. It's going to test his graphics capabilities, his processing speed, and all of his goodies.
So it's going to test everything from the start. Alright, you ready?
Alright, here we go. Alright, as you can see on the top, it displays the FPS, which stands for frames per second. Currently he's running 30, okay, it's going to fluctuate a lot, but it's going to go between 1 to 60 most likely, or it can even go above. But what resolution are you running this at?
1080p.
1080p? Okay, so then most likely it's going to be in the mid 30s to, what would you say?
I'd say from low teens for most of it to mid 30s.
Oh jeez.
Yeah. This thing really like my PC was not really built for gaming, it's more for coding and data storage. So I mean it does what it can for this, and I still use it for gaming too. This is just like completely like outrageous circumstances for games.
See right there, would you say that's physics? That's doing the physics engine with all the explosions and
yep.
all that fun stuff.
Particle effect for the
Particle effects. Do you have anti-aliasing on? Okay, so the battery in my camera died, so we're using my phone now. But so we went over the overall process and hardware and software of a computer. And we really hope you got something out of this video and that you learned something, more importantly. And if you have any questions, there's the comment section down below. And if you would like, subscribe for more, and we're going to make some more videos because we're in school now for that. And yeah, so rate this up if you liked it, and have a good day.